Hi, this is John Kamlo speaking. I'm a professor emeritus of economics at the University of Munich. I would like to tell you today about indifference curves, particularly how conventional indifference curves are wrong. It may seem odd to you, but all the lectures on the internet are basically incorrect. The incorrect indifference curves are taught to millions of students every year. Look at a conventional indifference curve. Looks pretty straightforward, except there is one thing missing. What is it? Well, it is the current level of consumption. The conventional analysis makes it out as though you come to this problem of choice between X and Y in a pristine state. It does not indicate the amount of goods that are being consumed at this moment. So we are assumed to come to the problem of choice between these two goods without indicating the amount of goods in question we consumed in prior period. However, this is obviously a contradiction, because if we have not consumed these goods in the previous period, then how are we supposed to know how much utility we should expect from them? It doesn't make any sense. Either we consumed these goods before, in which case we need to indicate our current level of consumption, or we've never consumed these goods before, in which case it's impossible for us to describe our indifference curve. So that doesn't make any sense at all. Well, does that make a difference? Well, of course it makes a difference because of something called the endowment effect. The endowment effect implies that there is an excess discomfort associated with giving up something, in excess of the pleasure associated with acquiring it. Here are all the people who have written about the endowment effect, and for some reason that I don't quite understand, the profession just seems to ignore this research. So let us look at behavioral indifference curves. Behavioral indifference curves need a reference point. This is the current level of consumption. Right here, a certain amount of X, a certain quantity of Y on this X. Now the point is that if I increase my consumption of X and decrease my consumption of Y, because I am giving up Y, I will require a lot of X in order to do that and still remain on the same indifference curve. Notice that all these 3 points are on the same indifference curve. And that's why this particular diagram has this angle at this point. So if I started with this reference point and I want to decrease my quantity of Y, will require a lot of X in order to compensate for that and consider myself indifferent between these 2 points, this point and this. However, if I go in the other direction, and that is the important factor here, if I'm going in the other direction, I am increasing Y but decreasing X, so I have a harder time giving up X and will require more Y for it. And therefore, the indifference curve is simply kinked at the reference point. It is not smooth as everybody draws it. This is kinked because at the reference point, the loss in marginal utility of giving up a unit of X in this direction is larger in absolute value than the marginal utility of obtaining a unit of X in this direction. Hence, the indifference curve has to be steeper in quadrant 2. So we have the reference point here. This is where we are consuming at the moment. And notice that if we draw an axis through that reference point in this fashion, those axes divide the plane into 4 quadrants: quadrant 1, quadrant 2, quadrant 3, and quadrant 4. Now in quadrant 1, the indifference curves are the conventional indifference curves because both X and Y are increasing. However, in quadrant 2 it is different. In quadrant 2, X is decreasing, so I am giving up X, therefore I require a higher price for it. Whenever I give up something, I require a higher compensation for it. That is the endowment effect. Similarly, in quadrant 4, I'm giving up Y. I'm getting less Y. So I will require a greater compensation for it in order for me to be indifferent between my current level of consumption and some other level of consumption in which y is decreasing, so that the indifference curve is flatter here and steeper here. So that's quadrant 1, quadrant 2, and quadrant 4. Now in quadrant 3, both are decreasing, and the slopes here depend on the extent to which the endowment effect affects my ability to give up x and y. It may be different. Here I'm drawing it in such a way that the endowment effect is the same on both x and y. The endowment effect may be different on x and y, and this slope may be different, but for the sake of simplicity, I'm drawing it like I have quadrant 1. So the main point to emphasize here is the kink. The kink is what makes this indifference curve different from the conventional analysis. And notice that there are kinks all along the axis. All these points are kinks. Notice that makes a big difference, because in the conventional analysis, optimizing behavior is a no-brainer. You have the budget constraint, and the budget constraint is tangent to an indifference curve, and that is what determines your level of consumption. However, things are different when we impose a budget constraint on these indifference curves. Here we have two different budget constraints that go through point A, the reference curve, but because of the kink, there is not a unique tangency between the budget constraint and the indifference curve, so that prices can change and yet your consumption is not going to change at all. That is a very different outcome than in conventional analysis, and can lead to what you might call sticky wages, sticky prices, where prices change but consumption behavior does not change. You may disregard budget constraint 3 for a moment. It may be that there is a tangency with these indifference curves as well, but my point is that because of these kinks, it doesn't have to be a unique solution to the problem. Thank you for your attention. You can read more about it in my new book, page 37, or follow this link and you'll be able to read about it as well.